Geometry, Lesson 8.5, more about angles and circles. So, in the previous section, we learned about the measure of inscribed angles, and an angle formed by two secants that intersected on the circle is 1/2 the measure of the intercepted arc. So in this section, we're going to talk about the measures of arcs formed by secants and tangents intersecting on the circle, intersecting in both the interior and exterior of the circle. So in our last lesson, these are some drawings that you should have. You had your two secants, and we had the secant that went through the diameter, the secants that were on the interior of the circle were in the interior of the circle but on the outside of the circle center, and in the interior of the circle but they were to the right or the left of the circle's center, and they were 1/2 the measure of the intercepted arc. So angle B would have been 1/2 the measure of arc AC. Our first theorem, Theorem 8.5.1. The measure of an angle formed by a tangent and a secant that intersect at the point of tangency is 1/2 the measure of the intercepted arc. Right now, you should pause the video, have your note paper out. Along with the pictures from the last lesson, you should now be adding drawings from this lesson with the theorems, and be sure to highlight, underline, bold, whatever will draw your attention to it. But tangent and secant on the circle or the point of tangency, 1/2 the measure of the arc. So as an example, the measure of angle ABC in this first drawing would be 1/2 of 154. Wait, where did we get that 154? Well, that's over here at this circle. Let's look at the arc. And I think they bring your attention to this one because this drawing is a little strange. But you can see that you have this tangent line, the secant line, they're meeting at a point of tangency, which is B, and they're intersecting, this whole arc AC, or AB. AB is 154, so it would be 1/2 154, which is 77. If you go to the first drawing to the left, ABC would be 1/2 of 50 degrees, which is 25. In the second drawing, 1/2 of 80, which is 40. In the third drawing, 1/2 of 120, which is 60. These are fairly above board, but the difficulty will be when you begin to see these tangent lines on the outsides of the circle, and they just look a little different than the other two examples to the left, and you may not identify them properly. Let's take a look at example 1. We have a circle Q. It has a major arc, and I'm going to do something right now just to make this be a little more legitimate. I'm going to add a point, and we have Q. Let's make this point R. Remember that when we name major arcs, they should have 3 points. Minor arcs will have 2 points. So, the measure of arc WY equals the whole circle, 360 degrees, minus this major arc, which is WRY. 360 minus 240 equals 120. The measure of angle WYX, and that is this angle right here, equals 1/2 of 120, which was our measure for this arc. So if this arc is 120, WYX equals 1/2 of 120, which will be 60 degrees. One of the things I'd like to point out is that you have a straight line right here, tangent line W, and Z is 180 degrees. And if this is 120, this arc WY, major arc WRZ is 240, so the angle WYZ would be 120, and 60 plus 120 equals 180 degrees. You'll see with these problems that they ask you to check that you have supplementary angles. It's just a way of making sure that you've done your math correctly. Let's do an informal proof of angles formed by secants inside a circle. So you can see that we have circle G, and we have two secants, BD and AC. They intersect at point E. You also can see that we're given that arc AB is 50 degrees and arc DC is 44 degrees. This means that we can now use our theorem to solve for our angle measure. One of the things they've done in this informal proof to prove that we're allowed to do this is they've drawn line BC. When they did that, this allowed a situation where angle 1 becomes an exterior of the two remote angles in the triangle that we created. So, if angle 1 is exterior to these two remote angles, the measure of angle ACB equals 1/2 the measure of arc AB and arc DBC. So once again, this measure using AC and then CB, this angle can be found by adding 50 degrees and 44 degrees and dividing it by 1/2. So that means that the measure of angle 1 will be 47 degrees. So what I suggest you do is make a picture just like this, and on our next slide you'll see the theorem, and as we go through the theorem, go ahead and mark the drawing so that you can actually get a better idea of how this will work. So theorem 8.5.2, the measure of an angle formed by two secants, there's our secants AC and DB, that intersect in the interior of a circle is 1/2 the sum of the measures of the intercepted arc. So angle 1 will be 1/2 of arc AB and 1/2 of DC. So that's much clearer than the actual theorem, but if you question how that can happen, the theorem is there for you to see how it works. Now in your paper, and I didn't do this the way that I wanted to, so I will right now, I'm going to highlight this you should have a picture, you should have the theorem, it should have two secants, then the word interior, and then 1/2 the sum. If you do this with every drawing, you'll have a secant, tangent, exterior, half the difference, and so forth. And this will make it easier for you to solve these problems. So example 2, let's find the measure of angle 1. So let's draw angle 1 right here. One of the things I note right away is that it intercepts arc JK, which is 85 degrees. Now the first thing that they usually have you do, you don't have to do it with every drawing, but it just helps, is to solve for the whole degree measure, the arc measures all the way around the circle. So we know that the circle is 360 degrees minus 85 minus 45 and then minus 120, and that will give us the measure of this arc that's unnamed, and that will be 110 degrees. So now you have all the arc measures. So we have 45, 85, 120, and 110. Now the measure of angle 1 is 1/2 of 85 plus 110. So 110 plus 85 is 195, and that equals 97.5. And that is our answer. If you want to check just to make sure, you can take the 120 plus the 45 and solve for angle JNM, and you'll find that it is 82.5 degrees, and you can add angle 1 and angle 2 together and they will equal 180 degrees. So you know you have it correctly. Next theorem, and the next few theorems will be corollaries of the first theorem we learned. So now you have the measure and angle formed by two secants that intersect in the exterior of a circle, and it will be half the difference of the measures of the intercepted arcs. So we have a drawing, we have circle O. Here we have our two secants, but they actually intersect outside the circle at point A. This forms several angles, but the angle we're interested in is angle 1. And angle 1 will be 1/2 the measure of CE and BD. And let me restate that just to make that, it sounded like I was adding it, I was not. So angle 1 will be 1/2 the measure of arc CE minus the measure of arc BD. Theorem 8.5.3b will be the measure of an angle formed by a secant and a tangent. So we have circle M, secant BF, and tangent GF. They are intersecting in the exterior of the circle at point F, and they will be 1/2 the difference. So if we're solving for this angle BFA, it will be 1/2 of the arc BA and minus the arc AE. Theorem 8.5.3c. This situation, or this case, will have two tangents intersecting outside of the circle, and you can see they intersect at point F, and they will be 1/2 the difference. You should you should be seeing a pattern here about where the lines intersect and whether you are going to add or subtract. So for the measure of angle CFA, it will be 1/2 the measure of CBA. And I'm going to get a highlighter for this. Okay. CBA minus arc CA. So once again, angle CFA equals 1/2 the measure of CBA, the major arc, minus CA, the minor arc. Now, be sure when you're setting these up to put your larger arc first in your equation and then subtract from your smaller arc. It doesn't matter what order they're in when you're adding them together, but when you're subtracting, you want to end up with a positive number, not a negative number. This is the final example 3. I'm saying that because my slide has disappeared twice and my program has locked me out twice. So prayerfully we get through this. So in this problem we're going to find the measure of angle YXZ. So YXZ. We're going to find the measure of arc WY and arc WV. We know that the measure of WXZ, the total measure of this angle, is 40 degrees. So once we solve for the angle angle YXZ, then we could subtract it from the total angle and solve for our remaining angle. So the measure of YXZ equals 1/2 of the intercepted arcs and their differences. So we have arc YZ, which is 145, and arc VZ, which is 88. So the measure of angle YXZ is 28.5 degrees. If we subtract the 28.5 from the total measure of 40 degrees, the other angle WXY will be 11.5 degrees. Now we're going to work on finding the measure of angle arc WV. So the measure of arc WV is part of this circle, which is A degrees plus 88 degrees plus 45 degrees from 360 degrees. So if we add all of these angles, or arcs, WV and A and 88 and 145, we get 360, and if we subtract them all from 360, we end up with arc WV equaling 127 minus A. I know that was a little roundabout, but this is the way we have to do it. Now, if we go ahead and move on, we knew that the measure of angle WXY equaled 11.5, and it is 1/2 of the measure of the two, of the difference of the two intercepted arcs. So this 11.5 measurement comes from arc A being subtracting this arc, which was 127 minus A. So A minus 127 minus A. The first thing we want to do is cancel out our fractions. So we'll multiply both sides by 2, and we end up with 23 equals 2A minus 127. And if we subtract or add 23 to both sides, and then divide by 2, we end up with 75. So we now have A equals 75 degrees, and that is the measure of arc WY. And to solve for the measure of arc WV, we can now say it is 127 minus A, so 127 minus 75 equals 52 degrees. So that was a little complicated, but the more you work with these, the better you'll get at identifying what information you need to solve. Your homework I'm sorry, everything moved over also. Your homework is lesson 8.5, pages 379 through 380, numbers 1 through 5, 7 through 15, numbers 16 through 18, number 20, 23, 25, and 27. And here's a few samples. So number 7, and for several problems you will use this drawing. What you're looking at is you're going to view the angle specified to solve the angle that you need. So for number 7, we need to solve for angle 1. If you look, angle 1 is a tangent, angle 1 is not a tangent. It's part of a tangent and a secant that meet outside the circle. So they intersect outside the circle, and this is theorem 8.5.3b on page 378 of your text. So that's what you need to identify. You need to identify which theorem it is, by what types of lines these are, and then how to solve. And we will be solving by using half the difference of the measures of the arcs. So the answer from your book gave you 3 choices, and your answer will be for number 22, we need to write and solve an equation to find the value. So let's take a look at what our figure is. We have a circle that is contains 2, or it's interacting with 2 secants. They intercept outside of the circle. We're actually solving for an arc measure, and I'm going to change this. And we're solving for arc X. So instead of solving for the angle, we're solving for one of the arcs. We will still use the same formulas. This is going to be 1/2 the difference of the measures of the 2 arcs. So it would be, and you have to write the equation out. You can't just give me an answer. 1/2 of 86 minus x equals the angle measure, which is 36. So if we multiply by 2 on both sides, we have 86 minus x equals 72, and x would equal 14 degrees. So this arc would be 86, this arc would be 14, and if you wanted to check, you could go ahead and substitute the 14 into the x and see if you have an answer of 36 degrees. Number 24, if you choose to do it, it's extra credit, 8 points. You have to give me a drawing, and I have to see the equations fully solved. Hopefully this helps, and we'll be moving on to constructions in the next video.